Good evening, student. So for the yesterday class, we have already discussed about the classification of function for one type, which is algebraic function. So today we will discuss about the transcendental functions. So types of transcendental function is trigonometry function, inverse trigonometry function, exponential function, and logarithms functions. So now we discuss about the trigonometry function, and for today class we discuss the construction of the graph of trigonometry function and find their domain and range. So the first graph is y is equal to sin x. So first we draw the x-axis and y-axis. We mention the point pi by 2, pi, 3 pi by 2 and 2 pi. Minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Then we mention the point here 1, minus 1. And we draw the strip line here like this. Now we know that sine pi which is equal to 0, then sine 2 pi which is equal to 0. So here we draw the curve and the graph of sine x like s, which is meet in pi in the x-axis, then again it's meet on 2 pi. Then for the similar for the left side, it's meet in minus pi, then again it's meet on minus 2 pi. So here in this graph, we see what is the domain and range of sine x. So here first of all domain. Here we see our curve which is lies between plus infinity to minus infinity. So therefore domain which is equal to R. And what about the range? Range, here we see that our curve, here the graph of sin x which is increasing between minus 1 to plus 1, then again it is decreasing from 1 to minus 1. Then again it's increasing on minus 1 to plus 1, then again decreasing in 1 to minus 1. So here the range is minus 1 to 1. Okay, so this is the graph of sin x, and for this graph we say here domain is R and range is minus 1 to plus 1. So for the next graph, y is equal to cos x. So first of all, we draw the axis line and mention the point. Pi by 2, pi, 3 pi by 2, 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. And mention the point here 1 and minus 1. So first we drew the step line here minus 1 to plus 1. Like this. Like this. So here we know that cos pi by 2 equal to 0. It means in the x-axis, the cos pi by 2 equal to 0. The next point is cos 3 pi by 2 equal to 0. So that's why our curve, which is meets in first pi by 2 for left side minus pi by 2. Then again it will go and meets on 3 pi by 2. Then next and so on. Then similar we draw for the left side. It's meet on minus 3 pi by 2. Then again and so on. So according to this graph, here we see the domain which is belongs to R. It means here we see our curve which is lies between plus infinity to minus infinity. That's why here domain is R. And about the range, here we see that our curves which is same thing, which is increase between -1 to +1, then it is decrease like this. This is decrease from minus +1 to -1, then again it's increase from -1 to +1. Then similar for it's decreased from -1 to +1. So our curve which is lies between -1 to +1. So the range is close interval -1 to +1. So this is the domain and range of the graph of cos x. Then for the next graph, y is equal to 10x. So first we draw the line and mention the point pi by 2, pi, 3 pi by 2, 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Then we already know that the value of 10 pi by 2, which is not defined, we know, and the value of 10 3 pi by 2, which is again not defined. So what we do here, we drew the strip line here because in this point the 10x is not defined. So that's why I drew here the strip line. Same for left side. So here what we see, when x equal to plus minus pi by 2 and plus minus 3 pi by 2, the 10x which is not defined. Now our curves which is draw like this, it's meet in 0, then 10 pi which is 0, then similar 10 2 pi again which is 0, then for minus x-axis minus pi, then the curve meet on minus 2 pi. So according to this graph, what is the domain and range? So first of all, domain. So here we can see this strip line. In this strip line, the point where 10x is not defined. So that's why when x equal to plus minus 2 plus minus 3 pi by 2 and so on, in this type of point, the function is not defined. It means the curve which is not meet in this line, or we can say this point is a asymptote. So therefore, the domain which is written as like r minus 2n plus 1 into pi by 2, and here n belongs to set of natural number. Why I write here 2n plus 1 into pi by 2? Suppose any value of n belongs to set of integer. Suppose we put n equal to 0. So what we get here? Pi by 2. When we put n equal to 1, then we get here 3 pi by 2. Then same for the negative value. So that's why I write here domain which is equal to r minus 2n plus 1 into pi by 2, and where n belongs to set of integers. And what about the range? In range, we see here our curves which is lies in all R. So here range is R. Now we go for the next graph. Graph of y is equal to x. So first we draw the axis, mention the point pi by 2, pi, 3 pi by 2, 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Okay. Then we know that the point cot of pi, which is not defined, and cot of 2 pi, again which is not defined. Same for cot of minus pi not defined, and cot of minus 2 pi. Again, it is not defined. Okay. Why it is not defined? First of all, why it is not defined? Suppose, so cot pi, which is right here, cos pi divided by sine pi. So cos pi, the value of cos pi minus 1, but the value of sine pi, which is equal to 0. So it is undefined. So that's why cos pi, which is not defined. Now we can draw the strip line where cot x is not defined. So we draw the strip line here. Then for 2 pi, again for minus pi and minus 2 pi. Okay. And for the x-axis, it means cot pi by 2, which is equal to 0, cot 3 pi by 2, which is equal to 0. Now we draw the curve here. So our curve, which is draw as like that. Okay. So this is the graph of cot x. So seeing, actually this time, this is okay. So according to this graph, here, what is the domain and range? So for the domain, here we see in some point, cot x is not defined when the point is like x equal to plus minus pi or plus minus 2 pi and so on. So in this point, the curve never meets, or also we can say it's a asymptote points. So therefore, here our domain is r minus n pi, and n belongs to set of natural number. Why I write here n pi? Because if we put n equal to 0, it means 0. N equal to 1 means pi. N equal to 2 equal to 2 pi. Then when n equal to minus 1, then minus pi, then equal to minus 2 pi. So that's why in general form I write here n pi. So domain, which is equal to r minus n pi, and where n belongs to set of integers. Then what about the range? So according to graph, we see here our curve which is lies between plus infinity to minus infinity. So that's why range is r. Okay. Then we go for the next graph. Y is equal to sec x. And from trigonometric identities, we know that sec x, which is equal to 1 upon cos x. So first we draw the graph, mention the point. Next 2 pi, then similar of minus axis, minus pi, minus 3 pi by 2 and minus 2 pi. Okay. So sec x, which is also equal to 1 upon cos x. So here first we draw the graph of cos x. Okay, first we draw here the graph of cos x, which is 1 and this is minus 1. Okay, there is one more thing. See in which point the sec x is not defined. In which point the sec x is not defined. So sec x, which is equal to 1 upon cos x. Okay. So suppose cos x, it means suppose 1 upon cos pi by 2. If you put x equal to pi by 2, so which is equal to cos pi by 2, it means the value is 0. So 1 upon 0, which is infinity. Then here we see the sec x, which is not defined in pi by 2. Okay. Then similar for 3 pi by 2. So first we draw the strip line here for pi by 2 and 3 pi by 2, because in this point sec x is not defined. Then similar for the minus x-axis. Okay, now we draw the graph of cos x. So the graph of cos x which is, we draw the graph of cos x like this, pi by 2, then 3 pi by 2, and so on. Then here, minus pi by 2, minus 3 pi by 2, and so on. So now the graph of sec x, see, which is lies between pi by 2 of minus pi by 2, minus pi by 2, minus 3 pi by 2, and this way. Okay, so according to this graph, here we see what are the domain and range. So first of all, domain. Okay, what about the domain? Here we see if domain, suppose, first of all, we mention the point where sec x is not defined. The point is x equal to plus minus pi by 2 and plus minus 3 pi by 2. Okay, so our domain here is r minus, again I write 2n plus 1 into pi by 2, and where n belongs to set of natural number. So why I write here 2n plus 1? Because we see if we putting x equal to plus minus pi by 2 or plus minus 3 pi by 2 in this point, the function sec x which becomes 2 undefined. So that's why when in the all real surface on real form, when we subtract the value of x equal to plus minus pi by 2 plus minus 3 pi by 2, then we got our domain. Then what about the range? Then range, here we see our curve which is lies except the point which is lies in all r, but except the point plus 1 to minus 1. Okay, so what is the range? So the range is r minus of minus 1 to plus 1. It is very clear. To according to this graph, it is very clear our range which is equal to r minus of minus 1 to plus 1. Okay, now we go for the next graph. The next graph is y is equal to cosec x. So cosec x, it means 1 upon sin x. So first of all, we find the points where the cos x is not defined. Okay, first I mentioned the point in the axis pi by 2, pi, 3 pi by 2, 2 pi. Then for the left side, minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Okay, and this is point 1 and this is minus 1. We draw the strip line for y equal to 1 and y equal to minus 1. Okay, so here our function is cosec x, which is also written as 1 upon sin x. So in which points it's become undefined. So suppose if you put x equal to pi, then sin pi. Sin pi, it means it is 0. So 1 upon 0, it means not defined. Then now we have idea about in which points the cosec x is not defined. So the points are pi, 2 pi, minus 2 pi. So we draw the strip line here on pi, 2 pi, minus pi, and minus 2 pi. Now we draw the graph of sin x. See, the graph of sin x like this. Okay. Okay. Then the curve of cosec x, which is lies between just opposite side 0 to pi. The next form minus pi to minus 2 pi. Then again 0 to minus pi and pi to pi. Okay. So according to this graph, here see what about the domain and range. See, in this graph, we see very clearly that when x equal to pi, 2 pi, minus pi, or minus 2 pi, it means x equal to plus minus 2 pi in these points, the cosec x becomes to undefined. So that's why our domain is, when we subtract r from this point of x, then we get our domain. So the domain is r minus n pi, r minus n pi, and where n belongs to set of integers. So this is the domain. And what about the range? See, our curve, which is lies in all r, but except the point of -1 to +1. So therefore, range is r minus -1 to +1. Okay. So these are the graphs explanation of trigonometry function, and we discuss about their domain and range. Okay. Now we go for the exponential function. Exponential function. Okay. So here fx, which is equal to a to the power x, and where a greater than 0 and a not equal to 1. And also x belongs to r. So for this function, see, it's arise two cases. Case 1, when your a greater than 1, and case 2, when a less than 1. So here fx equal to y, and y is equal to a into a to the power x. So we draw the graph of y is equal to ax. So the graph is like this. So y is equal to ax. So according this graph, here we can see the domain and range. So what is the domain? It is very clear, because our curve which is lies on the set of real number all r, so domain r. Then what about the range? Our curve which is open and upwarded side, so range is 0 to infinity. Okay. Then what about the case second, when a is less than 1? So the diagram of when a is less than 1, the diagram be like this. Okay, this is the graph of y is equal to ax, and where a less than x. Okay, same thing. We see here domain also are domain r, and range, which is again 0 to infinity. Okay. So this is the graph of exponential function and the domain and range. Now we go for the next graph, which is logarithms. Okay, just logarithms function. So the function fx equal to log ax, and where x comma a, which is greater than 0, and also a is not equal to 1, is a logarithm function. Okay, and when we draw the graph of logarithm function, see, for case 1, when 0 less than a less than 1. So the graph is like this. This is the graph of y is equal to log x. Okay, and this point is 1 and 0 for the condition of 0 less than a less than 1. Okay, and the graph of when a is greater than 1, then the graph of log x, which is equal to like this. Y is equal to x. This point is 1, 0. So according to this graph, here we see the domain. Domain which is equal to all real positive numbers. Okay, and about the range are of all real numbers. Okay, so to summarize for today class, we discuss about the transcendental function. We see the all details of a graph of trigonometry functions and find their domain and range through the graphs, and also discuss about the logarithm function and exponential function and discuss their domain and range. Thank you.